Hello students, in this session we'll discuss about the role of parser. So parser is main component in the compiler. So the compiler is mainly divided into 7 phases: lexical, syntax analysis, semantic analysis, intermediate representation, generation and optimization, code generation and optimization. So these two phases are collectively called as parser, and where the major portion is syntax analysis only. This is the main important phase of all compilation and even parser also. So most of the cases when the term used parser to represent the syntax analysis, but of course it also includes the semantic analysis functions. And first, where we are having the parser. See, even though the parser starts from the second phase of the compilation, but actually, whenever we call the compiler, the first phase to be called is parser only. So the parser role is to check whether a statement is syntactically correct or not by generating the parse tree for the stream of tokens. But as it is started first, so as it doesn't have any info about the token, then the parser calls the lexical analysis to generate the tokens. And whenever the lexical analyzer called by the parser, it starts reading the source program and prepare the tokens. And these tokens will be given to the parser. So then parser try to construct the parse tree for the stream of tokens by using the predefined context tree grammar. So if it could able to generate the parse tree, then the parse tree will be given as input to the next phase of the compiler. If it could not able to generate the parse tree for the tokens from the given context tree grammar, then we can say that syntax error or semantic error based on the phase. And whenever it needs some information about the tokens like properties, then the parser takes the information from the symbol table. And if we go for an example here, for example, output of lexical analysis is id plus id star id for the input symbol a plus b star c. Assume that. So this is the output of lexical analysis. And this is a predefined grammar. So without the grammar, you cannot define the syntactic rules. For example, even in our English language also, if you want to say that some statement is syntactically correct, first you should know the grammar rules. Someone has to define the grammar rules. Same way, we have to define the grammar rules or syntax rules for a compiler by using the context tree grammars. Now, if the output of lexical analysis id plus id star id could able to generate the parse tree from this grammar, then we can say that the statement is syntactically correct. Of course, we can check by using the derivation or by using the parse tree, which we have discussed in the ALC automata and language computation subject. So if you could able to generate the derivation, and that can be converted to parse tree. So if parse tree is derived for that input string, then we can say that the statement is syntactically correct, and this parse tree will be given as input to the next phase of the compiler. So the parsing is mainly divided into two concepts. One is syntax analysis and semantic analysis. So here it is going to perform context tree syntax analysis and of course semantic analysis, and based on this we can produce the proper or meaningful error messages, and sometimes we can correct the errors if there is an error handling mechanism. And as I told you, parser is mainly divided into two phases: syntax and semantic analysis. So some errors cannot be detected by the syntax analysis. For example, if sometimes we can even generate the parse tree even though there is a redeclaration of the variable, or if the variable is not initialized before use, in that case also we could able to construct the parse tree. Then even the mismatching of data types also not going to be detected by syntax analysis. So then who is going to take care about all these? So that will be deal by the next phase of the compiler, that is semantic analysis. See, these parsers are mainly divided into three types: top-down parsers, bottom-up parsers, and universal parsers. Of course, in our subject we are going to discuss mainly about the top-down parser and bottom-up parser. Just give some introduction about universal parser. I just mentioned two algorithms which are going to be used. So one is Cockinger-Kasami algorithm and Early's algorithm. So these are the best examples of universal parsers, but actually the universal parsers are inefficient to producing the compilers. So how it would be, we'll discuss with a simple example in later in the sessions, right? So but commonly used methods in compilers are either top down or bottom up approach. Even our complete unit is related about top down or bottom up parsers. So what does it mean by top down approach and what does it mean by bottom up approach? See, the parser means we are going to construct the parse tree from the root node, right? And we are going to find some nodes here based on the grammar rules, and we are going for the leaf nodes. So what does it mean by leaf node? The nodes which does not have the children are called leaf nodes. So these are the leaf nodes and this is the root node, and remaining all are called as internal nodes, right? Of course, this root node always must be the starting symbol of the grammar, and the leaf nodes must be the terminals, the strings what we are going to generate, the collection of strings, right? So then what is meant by top down approach? So in both the parsers we are going to generate the parse tree. That's the main intention of the parser. So top down means we have to start constructing the parse tree from the root node and we should go for the leaf nodes, right? So sometimes we need to reverse the parse tree and we have to apply the new productions, means we there is a possibility of backtracking while you are constructing the parse tree. And of course some parsers are predictive. Predictive means we have to substitute the production based on the input symbol. In that case there is no concept of backtrack. So we are going to discuss these backtracking required parsers and backtrack free parsers in the next session, right? I'm coming to the bottom up parsers. So the bottom up, so we have to start constructing the parse tree from the leaf nodes and we should go to the root node where the root node must be the starting symbol of the grammar, right? So here we are going to use some valid prefixes whether they are handle or not, and of course we'll use the sentential forms and stack to perform this bottom up parser. So later how all these are going to be useful while performing the bottom up parser, so we'll discuss. So in the next topic we are going to discuss about syntax error handling and recovery.